Okay, I want to go a little bit farther on this electric car and how we have set some of the control systems up in it and so on. As I told you before, it's a forklift motor. Now the forklift motor it's a good motor, but it is a bit overweight. Weighs about 250 pounds, which is about 100 pounds more than you can buy a similar sized motor that's made for electric cars. So there's some kind of a hit there. You look right here, you'll see there's a control box. This is a DC control box. I'm taking DC and pulse width modulating it for the throttle. This is not an AC system. I don't have the money for an AC system. So there is somewhat of a hit on these things because of the brush motors. They're not quite as efficient, I'm told. By the way, I don't have all the answers on this thing. I'm still looking for a lot of them. Things that I've done to make this thing work, the 20 batteries that are in this thing are golf cart batteries. They're 215 amp hours a piece. All batteries are in series, so you have a total of 215 amp hours. I don't seem to be able to drain those down much more than about half. And I'm not sure why that happens, but I do have some spreadsheets on this thing and how many amp hours I've used and so on. But the range on these things is, it's pretty much dependent on how many amp hours you can pack of the batteries and how many you can efficiently get out. I've looked at the electric motor. I've measured the temperature rise on it when it's running. I don't think it's losing much on the electric motor. I don't think there's a lot of efficiency losses there because the motor never reaches over 105 degrees. I haven't done it real hot outside temperatures, but at an 80-degree day, it still never gets over about 105. So I don't think there's a lot of losses there. Other things you can do is get rid of accessories. I have taken the power steering, and it used to be belt drive onto the shaft of the motor, and I've set it up with an electric drive with an electric drill motor, and I'll go into how I put that together. I don't know if it makes much difference in range, but this is a compressor. This is out of an early 80s General Motors AirShock car, and it was easily reversed to pull vacuum, so that's my vacuum brakes. This thing also has, and you probably can't really tell much about it here, this is an old 12-volt cordless drill. Let me get a little closer on this. Now perhaps you can see this a little closer. The drill is pointing down that way. There's a shaft that goes down to the brush ring, and I can move the brush ring back and forth about 10 or 15 degrees. And so I've been trying to make adjustments there for different RPM ranges to see if I can get a little more efficiency there. That doesn't appear to make a lot of difference. Jury's still kind of out on it, but doesn't seem to make a lot of difference. Okay, looking at the rear of this thing, as I've said before, we got 16 batteries back here. I've had to add 1,000-pound overload springs on this thing. This car, which weighed I think about 2,800 pounds with the gas engine in it, now weighs about 3,850. That's a pretty heavy car. Okay, I'm not sure how you can avoid that weight with lead acid batteries. These batteries weigh in at 65 pounds a piece, and that's going to put me at 1,300 pounds in just batteries. Although I did look up something on the Nissan Leaf the other day, and even the lithium batteries with the controller are about 660 pounds, which is about half the weight of this. They may have higher watt density. If you don't know what watt density is the amount of power you can pack into a storage battery. One of the reasons we don't use, although I'm not against using them, capacitors for batteries, is their watt density is pretty low. You'd have to have a whole pile of these things in order to get any actual storage out. They have a lot of advantages, but they get a lot of disadvantages, and if you start trying to get enough watt density, the cost is going to be a big issue. This thing uses onboard charging. I think I showed you that before. Right there, charging in 24 volt sections. There is some efficiency issues with battery chargers, and I have done a spreadsheet on that too, and we'll probably be going over that spreadsheet to look a little closer at that and see how much it actually costs me to operate this thing. The numbers that I originally came up with for how many watts this thing should take per mile, I did some calculations with a small car and using gasoline, 30 miles to the gallon, and the efficiency losses of the gasoline engine and so on, and I came up with about 300 watts per mile. Well, I was looking at a thing on the Nissan Leaf, and they are saying that theirs runs about 340 watts per mile, so it's actually fairly close. I'm not sure I could hold the 300 watts per mile on most runs. Most of my runs run a little more than that, maybe 325 to 350. And that's where we're getting this range of 30 to 35 miles. It's summer now, and I am going to take this thing on a test run, and I'm going to see if I can get my batteries charged up and make a specific test run on it and see what the actual is going to be in warm weather. I've done it in cooler weather where it was 35, 40 degrees, and I ended up with right around 30 miles. And we'll see if the warmer temperature makes a difference on the range. And I'll be trying other things to increase range on this thing, and we'll see how we do. But that's where we're at right now, and I'll start talking about more specific things as we go along.